All right, welcome everyone again to our second video here. We were just continuing on where we left off from the problem about the senior citizen tickets and the children's tickets. I apologize about the sound issue here. So what we were left with on the last video is negative 3s plus 76 equals 52. So if we solve to find out that senior citizen ticket, you can see that we're left with two negatives. But remember, it is okay to have those two negatives because when we divide negatives, they will cancel each other out. So then you divide by negative 3, divide by negative 3, and we find that a senior citizen ticket costs $8. Well, once we have that $8, we can substitute it back into our blob. So 3 times 8 gives me 24. So 38 minus 24, and we find that a child's ticket is $14. You could check your answers by substituting both your variables back in and see if they work. And I can tell you that they do. So go ahead and check those answers. But we are also going to move on here. Okay, so we talked about systems of linear equations. And that was when we looked at two equations, and we wanted to find their point of intersection. So where did they cross? So we looked at graphing it, substitution, and elimination. We've also looked at how to graph linear inequalities. So now we're going to kind of put those two concepts together, and we're going to graph systems of linear inequalities. And instead of a point of intersection, we're looking for an entire region of intersection. So we're not just looking for a point, we're looking for a whole section. If we're looking at this top left, let's actually look at the bottom in the middle here. You can see that the blue dashed line has a yellow section that is true. So any point that's in there is going to make that equation true. There's also a blue section that has to do with the red line, and that's going to make anything there. And then there's this green section. And that's what we want to focus in on, because it's where those two overlap. And that's what a system of linear inequality is where's the region that these two overlap. So you can see the yellow and blue make green, and that's why I really like this picture, is because it actually shows you in reality what you're getting. You're getting the two overlapping. If we look at the top left one here, we have a blue and a red, and so together they make this purple section, so that would be our region of any value that's in there is going to make those equations too true. The last one you can see is a little bit different because they're not color coded, but they're still light gray to dark gray. So this section here would be the truth. Any point in there is going to be true for this equation and this equation. Again, that's the goal, is that we want to find where it's true for both. So let's look at an example here. And our first example is already in slope-intercept form, which is perfect. That means we can just graph it. Remember then, this is going to be a dashed or a dotted line because there's no equal to. And this is going to be a solid line because it is equal to. So I'm going to graph this one in blue. So I start at a negative 2, and my slope tells me I go up 1 over 1. And then I can go down 1 and over 1 in the opposite direction. And I'm going to dash it. And I have my line. Then I can choose a point, and I'm going to choose the point 0, 0. And I'm going to see if it's true. So y is 0, and then I have x is 0 minus 2. So y is greater than negative 2. That means that I'm going to shade this top half here. So everything in yellow, every point that I choose in yellow there is going to be true for this blue dashed line. Now I'm going to go back and I'm going to choose a different color, and we're going to choose red for this line here. And I'm going to graph that line. So I'm going to start at a positive 2. And my slope tells me I go up 2 over 1. So I go up 2 over 1, and I also can go down 2 over 1. So this is a solid line because it's equal to. So now you can see that we're getting those three sections. We have a section that's on the left, in the middle, and on the right. So now we need to pick a point to graph to see where this is true. Now I don't want to pick 0, 0 for this one. This one is a little bit too close to 0, 0. So I'm actually going to choose 5, 0. So 0 is for y, and 5 is for x. So I get 0 is less than or equal to 12. And that's true. That means I'm going to take my blue and I'm going to shade everything on the right-hand side of that red line. And now you can see what happened. And this is the benefit of using a computer versus a piece of paper, is that now you know exactly the region of intersection. You can see it because it's green. It came up a different color as we were coloring. So anything that's in that green region, any point that's in there, is going to be true for both this line and this line. And that's the benefit. That's the goal of finding the intersection of a system of linear inequalities, is we're not looking for a point, we're looking for an entire section. Let's look at another example. Okay, so neither of these are in slope-intercept form. That means I need to get them in slope-intercept form. So I'm going to start with this one, and this one is now our solid line because it has that equal to. So I have x plus 3y is less than or equal to 6. Subtract my x. Divide by 3. So I get y is less than or equal to negative 1/3 x plus 2. So I started a positive 2. Now we know we need a negative line, so I'm going to go down 1 and to the right 3. Or I can go up 1 and to the left 3. Either way, I'm still creating that negative line. This is solid because it's equal to. And then we're going to pick our point. I'm going to pick the 0, 0 again. It makes it easiest. So I have 0 is less than negative 1/3 times 0 is 0 plus 2 is 2. So 0 is less than or equal to 2. I'm going to shade this in because that is my true section. Now I'm going to do the whole thing over, except I'm going to do it with the other line. So I'm going to erase our work here so we have some room to go. And I'm going to change the color so that we're using a different color. And now I'm going to do this line. This line is dashed because it's not equal to. So I have 2x minus y is greater than 2. Subtract my 2x. So I have a negative y is greater than negative 2x plus 2. I need to divide by a negative 1 on all sides. Because I divided by a negative, I'm going to flip the direction of my sign. Negative 2 divided by negative 1 is positive 2x. 2 divided by negative 1 is negative 2. So now I start at a negative 2, and I'm going to go up 2 over 1. This is dashed, so we're just going to dash it there. And now we have to, again, pick our point. I'm going to pick 0, 0. It's far enough away. I'm okay with that. I'm comfortable with where it's at. Again, you could pick something completely irrelevant. You could pick a point way up there if you want, or way down here. It doesn't matter, as long as it's on the left or the right. So I'm picking 0, 0. So I have 0 is in for y. And I have 2 times 0 is 0 minus 2, and I get negative 2. 0 is not less than negative 2. So that means that this point was false. That means everything on the opposite side is true. So again, you can see that green is coming out. That tells me any point in that section is going to be true for both this equation and this equation. So we want to find what's true for both of the equations. I really like doing linear inequality systems because you visually can see the answer. We could have substituted this, or we could have eliminated that. That's just fine. But when we're looking at them, you can graph them and you can really see this answer. It's harder when you are doing, I'm going to erase this just for a second. It's harder when you're not doing, when you have a pencil. So sometimes I've seen students where for the green line, they'll go this direction, and then they'll turn and they'll go this direction for the other line. And now you can see that point of crossing over is where they, the two lines are meeting in opposite directions, and that would be the true region. So that if you're doing it on pencil and paper, that's kind of my suggestion. Some students like to use 2 different colors. Again, if you're using it on the computer, it works best if you use a highlighter because you can see where they cross over. Okay, so let's look at our reminders here. 8.06 was talking about the applications to the word problems, and then 8.07 was the linear inequalities. I canceled Class Connect for Tuesday and Wednesday. Make sure you're using this time wisely. Get caught up on any possible assignments that you have. Any zeros you have um, can be still turned in, so please use that time to turn them in. Right now, the grade that you see is the lowest possible grade that you have. Once you turn in all your assignments that you need, it'll only get bigger from there. I did put all of the zeros in so you can see that this is the lowest grade you have. Again, some of them are not due yet, and I understand that. But I wanted you to see what the lowest possible grade you can get. All assignments are due this Friday by 5 p.m. unless we have something prearranged. You must have a 60% or above to pass. If your lowest score right now is a 60%, that means you're passing. Don't give up. That's not what I'm saying. Keep going. Get a better grade. And then we do have office hours tomorrow morning from 9:30 to 10:30 or Thursday afternoon like normal. So I will see you all on Thursday during class. And again, sorry about the video there. Have a great day.